Hi everybody, I'm making this little video with an example of how to solve a problem on nuclear reactions, and this one is on radioactivity, and I'm just going to do question 1. So the question is copper 64 decays by beta emission. And we have to write first of all a nuclear equation for this, and then we have to find out what is the mass deficit and how much energy is released, and then there are a couple more questions after that. So this is how you write the nuclear equation. So copper 64, and then I don't have enough details, so what I do is I have to look at this page where the information is given, and copper 64 is copper 64 29 decays by beta emission. So you can write it as an electron or a beta particle plus, now in any nuclear reactions, the nuclear number is conserved, so you still get 64 here because 64 plus 0 is 64, and there's a negative 1, so 30 minus 1 is 29, and element number 30 is zinc. So that's the nuclear equation, and the new product form is zinc, so copper becomes zinc with the emission of a beta particle. Now, in order to find the mass defect, the mass defect is mass of the reactants minus mass of the product. So the reactant is a copper, and the products, there are two of them. It's a beta particle and the zinc. So then I look at my table again. So mass deficit, which is just another term for mass defect, is equal to mass of the copper is 106.1873 minus mass of an electron is 0.00911 plus mass of zinc, which is 106.1863, and all this is times 10 to the power of negative 27 kilograms. Okay, so now when I put that into my calculator, I end up with, so let's go, so 106.1873 minus, open brackets, 0.000911 plus 106.1863, I get 8.9 times 10 to the power of negative 5. So I get 8.9 times 10 to the power of negative 5, and I also have the times 10 to the power of negative 27 kilograms. So 27 and 5 is 32. So the way that we can write this is 8.9 times 10 to the power of negative 32 kilograms. Okay? Now, in order to find out the energy that is released, because the mass of the products is less than the mass of the reactant, that means energy has been given out. Okay? So energy released is given by E equals mc squared. So my mass defect is 8.9 times 10 to the power of negative 32 times speed of light squared. So that's equal to, so I just go 8.9 exponent negative 32 times 9, because 3 squared is 9, exponent 16, because 10 to the power of 8 squared is 10 to the power of 16, and I get 8.01 times 10 to the power of negative 15. And this is in joules. Now there are two more questions, and the question says, assuming all this energy is emitted as a photon of electromagnetic radiation, calculate the frequency of the photon and state what type of energy this is. So photons have, the energy of a photon is related to its frequency by this equation, E equals hf, or frequency is equal to energy divided by Planck's constant. Your energy is 8.01 times 10 to the power of negative 15, and Planck's constant, that is given on this sheet right here at the top, Planck's constant. So we're going to use 6.626 times 10 to the power of negative 34. So if you divide that answer you got by 6.626 exponent negative 34, you end up with an answer like this, which is 1.209 times 10 to the power of 19. 1.209 times 10 to the power of 19, and it is frequency, so it is hertz. Okay? And then the question says, what sort of radiation is this? And we will know it off the top of our head, but there is a table on page 21 in your booklets over here. And then if you look at this table, I'm just going to look at the power of 10. So this could be either X-rays or gamma rays. It's very close. So, you know, X-rays are up to 1 times 10 to the power of 19, and this one is from 1 times 10 to the power of 19 and higher. So my answer would be just above 1. So it could be either X-rays or gamma rays, and that's the answer. And that's how you get those details. And I hope that was useful. So bye for now, and that's how you solve those questions under radioactivity.